Hi guys, this is going to be a quick little tutoring session on how you're going to develop a simulation in Simulink and a little bit of Matlab of a simplified model for an automobile suspension system. And so as you can see, we have the suspension system here, and then this U of T will be its little bump that it gets hit by. It's like our initial input, you could say. And then these are all your constants. And then here are your equations. If you don't understand how to build these differential equations, you can find multiple videos on YouTube for them that are going to break it down quickly. I wanted to have this main focus of this video to be on how to build a Simulink. So that's what I'm going to do. And like I said, if you just look up simple automobile suspension system differential equations, it'll come up. So first things first, we're going to have to build this little step function. Just to speed things along here, I've already done that and I made it a subsystem. And what this is going to do is you take a step, initial condition 0, when's it step, final value 1, that's what you want. And then this step time will be 2.5. You're going to subtract its value from this. That's why you have it. It's a negative in your output U of T. Prove it, I've plotted it. They look the same, 1, 2.5, and it's down. So now we can start to build these functions. And so I'm going to actually pull this over here. Which one do I want? This one. And so we can see the equations as we go about building them. So I'm going to start with the first one. And as you can see, you have ut minus x. So what we're going to do here is we're going to have our go-to blocks kind of leading us off. This will make a lot more sense once we get rolling, but we're just going to do this off the bat just to simplify it. And we're going to call this lowercase x. And so here you can see you have u of t minus x. So now we need a math operation. And we will grab this. Did I not grab it? Oh, I think I did. Some serious lag. Okay, there we go. So here. Okay. And it's as you can see, it's u of t minus x. So we just come in here, we make one of these minus. That simplifies that real quick. Bam. And then you need a gain, which is your K1. So you, oh, I had a big issue doing this. Okay. K1. And since we're going to use some help with MATLAB through this, we're just going to set this as K1 right now. I will display how to do it in MATLAB later. Now you have these functions. Again, we're going to go to our go-tos, and we're just going to grab from our froms. Y, and then we're going to take a K. We're going to pull this down as well. And so now we have y minus x, which is what we have over here. Drag this down, and this is going to be K2. Now all we need is our last piece, which is our y dots. And this, again, we're using our froms. Again, this will make much more sense. I'm just trying to make this in as much a concise video as possible. Y dot minus x dot. Your gain here or your, well, this is actually going to be your damping E. And there we have that. So now we need a big add block. We'll make him bigger. We'll come in here and you see all of our terms are positive. I do that. Put them all into this. Just try to make it a little nicer. All right. And then you see over here, you're going to be dividing by M1. So just the same as a gain, you're just going to put 1 divided by M1 and then run it through here. Oh, it does that if it's too small. Okay, there we go. And then we need to derive a couple times to get to your x's, and this is where it's going to start to make a lot more sense. If you go to your, oh, sorry, I think it's continuous. Yeah, continuous. You're going to grab your integrator formula, and before I do this, just move you back, zoom out a little bit. Okay, here. So you're going to have your integrator. You're going to go into the integrator one time, so, and you're going to go into it again. And this right here, just to make it easy, this is going to be your x dot. And then this is going to be your x, which now, like, this is where this is going to make sense. You're going to have a go to, and then this is going to be your x. And then you're also going to have another go to. Now let's move that up here. I'll do that, that'll be a little easier. And you're going to double click on him, and he's going to be your x dot. So now we've taken care of those two things, and now the machine isn't as mad at us as it is. But as you can see, we still don't have a y and a y dot. To clean this system up, it's a pretty good idea to just pull this out, the y and the y dot, out of the entire system. This helps quite a bit. As because you will still need, as you can see, your x and y dots from the other equations. And so when we do this, let's move you over here. Let's do both. When you make your subsystem, it's gonna look like that. It's gonna make it much smaller. That's a lot easier to deal with. Okay, and now here you can come and you can grab your out. This is important because you need these two to come out. And so for here, I'll just set this out 1. Sorry, I'll zoom in. This is x dot. You're going to pull in off this guy. I don't know why I made it so weird. And then again, come out here. This is your number 2, x. And so now when you look at all these things from out here, you have your x dot coming out and your x. I believe that those will be all you need coming out. And now we're going to start making our next subsystem, pretty much, is what it's going to be. And this one's a little easier because it's just 2 terms. Oh, oh, well, I guess you don't have to do that. It's not the worst. What I would do here is you take your, again, your go-to, you have a from, That's a y. And you have a math operator. Again, you're going to be running with a minus. And that goes in there. And then you can pull that one straight from there. And so you already have that one completed. That will be multiplied by K2. K2. After that, you will need x dot minus y dot. So I would pull this and this tag y dot. And this gain, if you look over on the right, is, oh geez, I did that twice. So like that one. Is now going to be b. And then once again, you will have to divide the whole, you have to add these two together and then divide by its mass. Just no big deal, I just leave that. And once again, it's going to be 1 divided by m2. A little bit. And then once again, you will hit it with your integration. I go to continuous integrating. And this will be y dot. And then grab your go-tos. And now everything should start lining up completely. Here's your y. And then here's your y dot. And once again, to make this a little cleaner, I like to dump these all again into a subsystem. As you can see, you know, these guys still don't have any because now it's in a subsystem. There's nothing we can't fix. We come back in here and we go to our sinks. We grab our out. Out 1 will be y. Out 2 will be y dot. And then we can come up and then we make go-tos again. And if you remember from the beginning of the problem, we are looking for y. And so at this point, we will need our, again, go to sync so we can display it to the workspace. So you can just drag him out. Again, we're just looking for y, y out. Okay. Oh, yeah, I just missed the line. That's weird. Let's bring these all closer together. Okay, so now we have all this. And so now we can go into our Matlab and we can input, well, actually what I like to do is I like to open a script. This makes things run a little smoothly, more smoothly. So I have the paper here next to me, so it'll make it a little easier. This is just 2,000. E2 equals 6,000. 1 equals 1 kilogram. And 2 equals 1.3. And then B equals 200. And then if you use the command sim, I forgot to name this. I'm gonna name the suspension car. Yeah, I mean, it's kind of backwards. Suspension car. All right, file, save. I just made these earlier, but let's just dump these in Matlab. Let's go to script. All right. We are one step away now. All we have to do is save this. Let's just throw this in the same folder just to make sure. Suspension car. Suspension car, cool. And after this, we will plot our T out and our Y out. That's what we specified it as. One more thing before we run, just to make sure we're doing this correctly. Let's just check our simulation parameters. Okay, 10 seconds, that's what we wanted. We'll go here, it's being executed out. Additional parameters. I always like to do produce specified output, because then as long as you do it correctly, so it's 0.01 and then 10, apply that. Okay. Oh, and then also on this, you have to make sure this is an array or it's going to come out very bad. And okay. So now everything should be able to run. And if we just give it a second to compile, this is what you should be left with. As you can see, it moves up slightly. Vibrations go to nothing. I hope this video helps any of you guys out there taking controls. I know it can be kind of really extremely confusing at first. I know this is a quick video, but I'm hoping if you slow it down, pause it, and whatnot, it'll make a lot more sense. Thank you, and good luck in the course.